So, we have been discussing about quantum entanglement. Now, let us see that why quantum entanglement is so surprising. So, let us perform a measurement just prior to application of the CNOT gate, which had been discussed earlier. In short, we will call it as QE. So, perform a measurement just prior to applying the CNOT gate. Okay. So, the two measurement operators are so this is corresponding to obtaining 0 or 1 state are. So, it is a M02. So, which is written as 1 0 0 0 0 0 0 0 0 0 1 0 and 0 0 0. In addition to that, so there is a M12 which is equal to 0 0 0 0 0 1 0 0 0 0 0 0 and 0 0 0 1. So, these are the two measurement operators. So, if you recall that prior to application of the CNOT gate, the system is in psi 1 prime and a psi 2, which is equal to 1 by root 2 0 0 plus a 0 0 1 plus a 1 0 plus a 0 1 1. So, this is very apparent that the result of measuring the second qubit, it will always be in the 0 state. So, it will be in this 0. Okay. So, let us also note that M02 dagger M02 it's equal to M02, and so the probability of getting 0 for the measurement of the second qubit, which we just saw that it to be 0, but we can also prove that. So, this is P 0, which is equal to psi 1 prime psi 2 and M02 dagger M02 and a psi 1 prime psi 2, which is nothing but because of this relationship above. So, it is psi 1 prime psi 2 and m 0 2 and psi 1 prime psi 2. So, this if you do it explicitly, then it is bra of this is that psi 1. So, this is that psi 1 prime psi 2 which is here, and then we will write the m 0 2 which is what we have written, and so this is m 0 2, it is 1 0 0 0 0 0 0 0 0 0 1 0 0 0 0 0, and now I will have a 1 by root 2 0 1 by root 2 0, and if you simplify this, it becomes equal to 1 by root 2 0 1 by root 2 0, which you should check, and 1 by root 2 0 1 by root 2 0, which is equal to 1. So, after the measurement, the system of qubits is again found in the state psi 1 prime psi 2. So, essentially what we are saying is that the measurement had no effect on the first qubit, it remained in the superposition of 0 and 1. So, now consider the same measurement, but just after the CNOT gate is applied. So, that would mean that we have a new state psi which is psi 1 prime psi 2 and then this double prime, which is equal to 1 by root 2 and a 0 0 plus a 1 1, as we have seen earlier. Now, it is not clear whether the second qubit will return to a 0 state or a 1 state on measurement, because both seem to be equally likely. So, the question is whether the second qubit will return a 0 or 1 on measurement because both outcomes are equally likely. All right. So, we will now apply the CNOT gate and do the same measurement P of 0. So, a P of 0 on this new state psi, which is written here, this new state psi. So, this is equal to m02 dagger m02 and psi, and this is equal to psi m02 psi. So, this is 1 by root 2 0 0 1 by root 2 1 0 0 0 0 0 0 0 0 0 0 1 0 0 0 0 0 and the new state again in the ket form 1 by root 2, and this is, if you simplify, it becomes half. So, what was 1 here on the state that was before application of C naught, now after application of C naught getting a 0 for the second qubit becomes half. So, after C naught gate is applied, we have only half chance or half possibilities or probabilities. Possibility of obtaining a 0 for the second qubit. Okay. So, so just to rerun things once more, suppose we have the two measurement operators which are given as m02 and m12, which are corresponding to for the second qubit, if we want to measure it in the 0 state and to be measured it in the 1 state. So, now prior to application of the C naught gate, this is the state that if you remember that we have obtained by applying U or H on the qubit on the bell pair. So, this is equal to half 0 0 and 0 1 and so on. So, the measurement of the second qubit will be 0. So, now in order to see that comprehensively, we have applied. So, this is the probability of getting it 0. We have taken the state and have squeezed this m02 dagger m02, which is simply equal to m02, and we get equal to 1. So, the measurement of qubit is the second qubit is always in the 0 state, whereas if we operate the state, that is this psi 1 prime psi 2 on, if we operate this psi 1 prime psi 2 by the C naught gate, which it becomes psi 1 prime psi 2, and then we write it with a double prime, it becomes equal to 1 by root 2 0 0 and 1 1. Now, this has been discussed earlier. So, when now again if we consider p of 0, that is the probability for the second qubit to yield 0, we get only a probability of half, and this is what is written there, that prior to C naught it was 1 and after applying C naught it is half. So, let us now ask this question: what happens to the state vector of the system? So, after measurement, it's psi and divided by root over of psi psi. In this particular case, if we take m to be equal to that operator, the measurement operators that we have just introduced. So, it will be 1 by root 2 and we have a 1 0 0 0 0 0 0 0 0 0 1 0 and 0 0 0 0 and we have 1 by root 2 0 0 1 by root 2 and that is equal to nothing but 1 by root 2 1 by root 2 0 0 0 and this is equal to 1 0 0 0 and which we can simply call it as 0 0 because all other entries are 0. So, in fact, this is the remarkable thing about the quantum entanglement. By measuring one qubit, we can affect or rather determine the probability of amplitude of the other qubits in the system, in principle all other qubits in the system. So, entanglement links the information across the quantum bits, but it does not create any more of them. So, let me write down the most important part. By measuring one qubit, we can affect the probability amplitude of all other qubits in the system. Thus, quantum entanglement links information across the quantum bits but does not create any more of it. Okay. So, this abstract concept can be important for quantum teleportation, where quantum state can actually be carried from one location to another remote location without having to make journey along the way. So, this will be the next thing that we look at, quantum teleportation. Let me give you a very brief introduction to it. So, quantum teleportation refers to the transport of the quantum state of a system and its correlation across the space to another system. It was first coined in a book by the science fiction writer, let me just correct the spelling, it is a writer, C.H. Fort in 1931. The word teleportation has been used to refer to the processes by which bodies and the objects can be transferred from one location to another without actually making a journey along the way. Quantum teleportation is a protocol where an unknown quantum state of a physical system is measured and subsequently reconstructed, or which is also called as reassembled at a remote location. So, this process required classical communication and exclude superluminal, which is what it means is that the faster than light, which is why Einstein has raised the question that is quantum mechanics complete, because nothing moves faster than light is the postulate of the special theory of relativity. If there is a superluminal communication possible, which means that faster than light communication possible, then quantum mechanics would contradict the postulates of special theory of relativity, which is what Einstein had his and the other people as well had their apprehensions. However, this quantum teleportation does not require, or rather it excludes superluminal communication, but it requires the source of, or the resource of, a quantum entanglement, which is what we had just seen. It also plays an active role in the progress of quantum information science and quantum technologies, and it will go a long way in terms of research in order to have quantum teleportation possible. And so, it was originally of course proposed for 2-level system, the so called qubits, but then it can also be extended to the qubits or the qubits and so on.